Okay, today we're going to continue our discussion of quadratic functions, and this time we're focusing more on standard form of a quadratic function. And remember from the other day, we said that standard form of a quadratic is f of x equals ax squared plus bx plus c. Remember, the other form is vertex form of a parabola. And in this form, the a can't be equal to 0. We have to have an x squared there in order for this to be a quadratic function. Both the a, b, and c provide key information about the graph itself. Remember the other day we used axis of symmetry formula, x equals negative b over 2a for the axis of symmetry of a quadratic, and we also looked at the c value for the y-intercept. So now what we're going to do is find the vertex, axis of symmetry, min, max, and range of quadratics, and we're going to look more specifically at the standard form itself. So what I want you to do is work on exercise 1. And pause the video, and when you come back to the video, I will have all of the questions that I'm asking you, I'll have down on the video. So go ahead and press pause, and you figure out the vertex, axis of symmetry, max or min, and the range for the given quadratic. Okay, so hopefully you found your vertex to be the ordered pair -2, -10. And remember that the axis of symmetry is x equals, and it's always the same x value as what the vertex is. This is a minimum parabola because the parabola opens up and its minimum value is -10, which is also the y value of the vertex. And the range goes from -10 to infinity, and we include the -10. Of course, we don't include the infinity. Okay, now properties of quadratics. Remember when we have f of x equals ax squared plus bx plus c, where the a does not equal 0, we have a parabola. When the a is greater than 0, or in other words positive, the parabola opens up. And if the a is less than 0, meaning we have a negative value, it opens down. The axis of symmetry is x equals negative b over 2a. That's going to be an important formula for you to memorize. The x-coordinate of the vertex is that value, negative b over 2a. And then we substitute that x value into the quadratic to get the y value for the vertex. And remember that the y-intercept is the c value. So all of that we've talked about before. We're just going over and recalling some of that information. On the next page, what we're going to do is we're going to expand vertex form of a quadratic to determine the properties of the graph of a quadratic function written in standard form. So as you notice, I gave you vertex form, f of x equals a times x minus h quantity squared plus k. And what I want you to remember is that the axis of symmetry is x equals negative b over 2a. But in this case here, and when we're in vertex form, we can't get that axis of symmetry based on the information that we have here. Remember, our vertex, when we're in vertex form, is the ordered pair h, comma, k. And it's the opposite sign for the h value and the same sign for the k value. So what we can do is we can find the vertex first when we're given vertex form, and then the axis of symmetry would just be the h value when we're in vertex form. Okay, down to number 2. Without making a table or using your calculator, graph the function y equals x squared plus 2x plus 3. So the first thing we're going to want to do is find out where the axis of symmetry is for this guy, and its vertex. I want you to also notice that this is a smiling parabola. Okay, and now we're going to find the vertex. So x equals negative b over 2a. Your a value is the number in front of the x squared. Your b is the number with the x. And the c is the y-intercept, the number by itself. So if I come back to my axis of symmetry formula, negative 2 over 2 times 1. And negative 2 over 2 is negative 1. So that's the x value of my vertex. In order to get the y value, I go back to my function and I substitute negative 1 into the function. So I'll give you a few seconds to figure out what the y value is. And the y value is going to be equal to 2. So that means the vertex of my parabola is the ordered pair negative 1, 2. So when I come over to my graph, I'm going to label my x and y axis. and plot -1, 2 for my vertex. And remember, I know that this is a smiling parabola, so my parabola is going to open up. Now, the other point that I know is the y-intercept. Because I'm in standard form, I know that the y-intercept is at 3. So what I'm going to do is I'm going to plot another point on the y-axis at 3. And since parabolas are symmetric, I know that I'm going to have another point at -2, 3 to reflect the point, the y-intercept point. And now I can start to see the makings of my parabola. Now, of course, this is just a sketch of this parabola. If we wanted to be more exact, we would use the graphing calculator and make a table for this parabola. Okay, for example 3. Now we're going to convert y equals 2x squared plus 10x plus 7 to vertex form. So notice this is standard form, and I want to go to vertex form, which is y equals a times x minus h quantity squared plus k. Now, in order to go to vertex form, I need to know what the vertex is. So I'm going to do x equals -b over 2a to find the x value of my vertex. Remember, the a is the number with the x squared, that's 2. The b is the number with the x, and the c is the y-intercept, or the number by itself. So x equals -10 over 2 times 2. So x equals -2.5. So that's the x value of my vertex. Now, in order to find the y value of my vertex, I take that x and I substitute it back into the function. -2.5 quantity squared plus 10 times -2.5 plus 7. And again, I'll just pause for a minute and let you put that in your calculator so that you can figure out the y value of the vertex. So hopefully you got y equals -5.5. Now we know that the vertex is the ordered pair -2.5, comma, -5.5. And now, to find vertex form, all we need to do is substitute those values into vertex form. Y equals a, which I already know is 2, times x minus, the x value of the vertex is -2.5, quantity squared, plus k, which is a -5.5. And I'm just going to clean that up a little bit. Y equals 2 times x plus 2.5, quantity squared, minus 5.5. So if I want to go from standard form to vertex form, it's pretty easy. All I need to do is find the vertex, substitute the vertex in, substitute the a value in, and I'm all set. Okay, on to example 4. Now what we're going to do is we're going to interpret quadratic graphs. So what I want you to do is I want you to read over the question. I want you to get a sense of what's happening here. And then when you come back to the video, I'll start going over the problem. Okay, now that you've had a chance to read over the problem, I want to point out a few things. This arch right here is the parabola that we're talking about. And our goal is to find the height of the arch. And I want you to notice that that is the y value for the height is the actual y value, but that line there is the axis of symmetry. So I can find the axis of symmetry, which is going to give me the x value. That's this value here. That's my x value. That's going to give me the x of the axis of symmetry. So I have the function y equals -0.000498x squared plus 0.847x. And I'm going to use my axis of symmetry formula. X equals -b over 2a. So -0.847 over 2 times -0.000498. And again, I'm going to pause for a second and let you figure out what the x value is there. and hopefully you have 850.4016. And I'm rounding it there. Okay, now remember, I didn't want the x value because that was telling me how far over I had to go. What I wanted was the y value, which tells me the height of the arch. So I'm going to take that x value and substitute it back into the function to get the y. Okay, and once again, I'll give you a minute. We're not going to use the graph, so don't worry about going over onto the graph. We're not going to graph this again. I'll give you a minute to figure out what the y value is, or the height of the arch. So hopefully you calculated the height of the arch as 360.145. Again, I'm going to be rounding feet, and that's the height of the arch. Okay, now the question says, how high above the river is the arch? So what I want to know is, what is the total distance from the river itself to the very top of the arch? Well, I already know now that this y value here, the height of the arch itself, is about 360 feet, but I also know that from the river to the bottom of the arch is 516 feet. So all I need to do to find the total height, or the height above the river, is to add those two numbers together. So I'm going to take the y value that I just found and add 516 feet to that. So again, I'll give you a second to calculate that. And hopefully you get about 876.145 feet. Now what they want to know is, what is the length of the bridge above the arch? So they want to know the length of the bridge above the arch. So if the arch goes from here to here, they want to know the length of the bridge, this distance right here. Now, we've already calculated part of that distance. We've already calculated this distance here. We have that x distance, and if you remember that x value cuts the parabola in half. So all I need to do is take my x value to get the length of the bridge and multiply it by 2. So I take 2 times the x value that I calculated, which was 850.4016, to get the total length, which is 1700.803. Okay, so you're going to be working on a worksheet, page 206 and 207 for homework tonight, and then tomorrow we're going to continue our discussion about quadratics.